All right, welcome everyone to this talk, from batch to real-time with Hadoop. Puts together ideas and concepts that we have seen in practice while consulting customers. About me, I'm a solution architect with Cloudera. So I'm going to customers and help them come to terms with Hadoop, help them from, 0 to 100%, setting up something from scratch to a deployable solution, or 80 to 100%, or whatever it is they need help with. I'm going to customers and see these things basically developing there in real life. I'm also an Apache HBase and Weir committer, so I have a bit of a technical background, although my recent track record in terms of engineering is rather poor, so I'm not claiming that for me. It's just, I have karma, and I can be dangerous if I have to be. I'm working with HBase and Hadoop since 2007. Back then, I wasn't with Cloudera. I was with another company called Lingo. I was the CTO, and I only had the choice. I had to store like 450 million documents somewhere, and somehow also make this searchable. And the only way I could do this back then was either do it myself, use something like Postgres or MySQL, or this new thing called HBase and Lucene. So that was my attempt back then, using HBase and Hadoop underneath and Lucene for the search index. So I had like years of pain. Not with Lucene, but with Hadoop and HBase. I'm also the author of the HBase book it's published by Riley. So if you're interested in HBase in any event, it's the only one out there anyway, so you might want to read that. Let's get started. So back in 20 years ago, so I'm really just going a big step back. There was this whole idea about we need to somehow rebuild the same things over and over, because everyone wanted to build a website. We need to have components to do that. We needed a couple of tools to run that, a web server, an application server. So out of that, the need was created to create an application stack that solves business goals. So you had a target, you had a goal, and somehow you needed components and tools to get there. And you wanted to have something that is reliable, so that should work. You don't want to have to reinvent the wheel every time you do the next iteration, the next product. Has to be rather fast. You don't want to do something really quickly, prototype quickly, and use like templates, MVC, model view controller, all of these buzzwords from back in the days. So we have today this Buzzwords conference, so I can throw out a few more. And you want to do this in cycles, right? So let there be light. So the whole idea is, back in the days, this thing was a LAMP. And as you all know, LAMP means Linux, Apache, MySQL, and some form of templating language, Perl, PHP, and whatever you fancy there. And that worked for a while. I mean, that was back in the 90s when it all started with Apache web server, or with Linux and all the tools. Was really like a pleasant experience. You could prototype something quickly, set something up, put it on the web, and back then you had like an audience of, say, 50,000 readers or 50,000 users. That was great, right? So this thing worked out of the box. Obviously, these are not the numbers that we talk about these days. Back when you were doing this, you were like quite local. You would probably serve only your local area, not just the country, but maybe just the local area. Serving your country was already a big deal back then. And nowadays, you want to serve the world. So that worked for a while. And but over time, this got a little bit slower. So what do? So the next thing you do, obviously, you add a caching layer. And surprisingly, 20 years later, that thing still is up and running and in use in a lot of places. In different incarnations, might it be now being wrapped in Ruby on Rails or whatever you call that. But the overall idea that you have a web server, some templating, and some caching to cache the heck out of the front end is quite common nowadays. So that works, and why should you change it? The problem here is that, as I mentioned, back then you only had a small audience. You were just collecting the logins. The log files were stored somewhere, and it happened to me. I had log files. And as I added servers, because I had to scale out, I used Linux Virtual Server and like all of these different tools that you could use back then to route the traffic. These days you could maybe use typical is like HTTP proxy, and other tools to route the traffic across the servers. That's all great. And what happened is this one server that I had that was doing the log aggregation was obviously too slow after a while to keep up with 10, 20, 30 front-end servers that created those logs. So I could not catch up with log analysis. And for years, I'm not kidding you, we had no statistics. I was flying blind. I had no idea how many users I had, how many unique users. I just had no time, no money, no budget, and no machines to catch up with the logs. The logs were more and more, and what do you do with it? So this whole thing, and this is just like one tiny little story of me, one person somewhere sitting in some country, somewhere in the world, and trying to cope with the data that you collect, right? In general, this thing took off. That's why a lot of people are here. Scalability, the big data is like the buzzwords. I mean, if you have to put like the sort of the combination of buzzwords, big data, I think is one of the top up there, because it's all about generating data. And coming back, because of my background being employed by an American company but working mostly Europe, I have to say that big data should not shy you away. Big data is not all about lots of data, like lots of log files, lots of, I don't know what data you store in your clusters. It's also about big computation. So I try to sort of get away from this whole big data buzzword and just say it's about processing at large as well. So it's nice that you have a lot of data, but a lot of entities in Europe, they don't have that. But you still have the need of coming up with new ways to crunch data that you have already collected or you're currently collecting, and these sort of solutions help you there as well. You can like, prototype things and analyze data much quicker, much faster than was previously not possible. So big data is it's too heavy on the data part. But as you can see here, you get like all of these, any vertical, but even like the brick and mortar companies like the smart grid or financials and telcos, or like any company that is not public or not really visible on the web, not these web properties that you typically think of. We don't have an eBay, we don't have these big companies, we don't have an Amazon in Germany, we have large sites, and in Europe in general. I mean, we have large sites in our countries, but if you look at the overall usage, that's minute compared to what Facebook pushes through and the likes. I mean, these are all way out there. But in general, you have the same problem, so you generate a lot of data, so even the brick-and-mortar companies do this, and somehow you have to cope with that. In the past, what I have seen at customers, they were sampling data. So they were collecting data, and instead of having the power or the machines to somehow analyze all of what they were collecting, what they were doing is just picking a few files, out of these files, subsections, and do some heuristics over the files, sampling over them, and sort of deriving, with an error rate, what the real number would be. So you shouldn't do this, right? If you want to be spot on, you have to be spot on and not just start introducing an error into your computation. So that's something that happened, it happens now, but it shouldn't. And we want to add more algorithms. You want to do some machine learning, and you want to just add on top of that. And there are papers like this unreasonable effectiveness of data that proves that more data is good because you can have simpler algorithms on more data are more accurate than really, really smart algorithms on a little subset of data. So it's good to collect a lot of data and run simple algorithms over terabytes of those. Out of that, Google came out with this paper, multiple papers, HDFS and MapReduce, and out of that came Hadoop eventually. So Hadoop was an implementation of that technology on top of the papers that we have. So it's quite different from what Google runs, but from the concept is the same. So the idea is that you have a distributed storage and computation framework, right? So I mean, I'm not telling you, hopefully not a lot of new information here. If you haven't heard or haven't been too deep, maybe from the search side or so, and you want to hear about Hadoop, I'm hoping that gives you enough high-level overview. So you have two different components in Hadoop. Nowadays, when we talk about Hadoop, that's actually not MapReduce and HDFS anymore. Hadoop is actually an ecosystem. If you look at companies today, just using a MapReduce framework and a storage framework for HDFS is great, but it just doesn't answer a lot of questions. So you need to have tools that you can, for example, run an SQL query against the data, or run some other sort of front-end tool that you can use to formulate queries against the back-end system. So out of that, a lot of systems started to develop around Hadoop, join the course, and help out. So when I'm talking about real-time, whatever it is with Hadoop, that's basically not just MapReduce and HDFS, because that is inherently batch-driven, right? So we're talking about the ecosystem and what can be done with the tools around it. It's affordable, it's free software, and has a significant adoption. I don't think I have to explain this. There's two components. I mentioned this, HDFS, MapReduce. HDFS is the part that stores the data, replicates a couple of times across the machines. We had yesterday, a colleague of mine gave a talk about the whole intro to Hadoop and the different components. So it's basically a master-slave architecture. You have a name node, you have data nodes that store all the data. So that all works quite well. It's built on commodity hardware, so it's cheap. On the other hand, you have MapReduce, which is the processing framework. That's the one that lets you process data across all of these nodes. So you have locality, that's really important. So when you run a job, that job is being sent to where the data resides, not like in other frameworks where the data gets pushed around because it's typically quite small. Here you basically have lots of data, so you ship the code to where the data resides. The code is running there locally. The data is then aggregated in the reduce phase, and then at the end spits out results. So that's a very nice concept, but it's not the only one, right? So this is that works quite well for certain use cases. And it's inspired by functional programming with the map and reduce function, so nothing, I don't want to slide in the slightest what Google has done, but really if you look at the concepts, they just took best practices or great ideas of other languages and other tools and other engineering fields and put them all together and scaled this out to what is now Hadoop or huge clusters at Google or say Yahoo or Facebook. The steps are always, you put something in, you map it, then it gets basically moved around the servers. So here's the locality part, then it gets copied over the network, gets aggregated, and an output gives you the results. So that sounds like a good idea. So you have the next step. I told you that when you store logs on your machine, and I had this problem that I could not keep up with these logs, what do? I can maybe zip them somewhere and store them somewhere. Eventually, I run out of storage space. So what I do, I delete that data. So sooner or later, short term is basically for me a couple of days, a couple of weeks, but that's it. But ideally, you want to have something that goes long term. You want to have something where you can keep the data ideally forever, because you want to learn from that data something that you can't tell today. How can you tell today that you need to crunch the data for a certain data point? You don't know that. So you don't have the algorithms, but you need to retain the data that by the time your analysts come up with the ideas of how to slice and dice the data, you need to have the data retained somewhere in the storage facility. And basically that's what it is, right? So what you do is you extend the LAMP stack. This is one here, which serves the client and stores intermediate data, which is the short-term storage, and you put a Hadoop behind it. I mean, it's straightforward. Hadoop means I can create a small cluster with terabytes of data already. I can scale it out as I need to. Running costs are fairly moderate, so I don't really have to worry about that much. And I have that long-term processing, long-term storage. And at the same time, because I have bought these servers or I have rented these servers, this can be anywhere. It could be even in EC2, although this is questionable about like the cost in the end. But you can actually rent servers or buy servers, and then you also have the computing power. Now you can actually do number crunching, and that is what is known as batch processing. So we have an unlimited scale, means that you're also bound by hardware. There is, of course, there are some limitations, and as you might have followed Hadoop, there's development being done by different companies to overcome current limitations, but there will be always some sort of limitations because no one else has done it better. So there was some sort of limitations of about, say, 4,000 to 5,000 nodes in a Hadoop cluster. After that, it's sort of not really worked that well anymore, but who has that? There's only a few in the world that have that. And on top of that, with the new development, you can go, say, to 10,000, 15,000 servers again, who has that. But again, there's some sort of cap, but overall, this can be fixed, and it can grow, and you can run at any data scale that you want. You harness the power of every machine in your cluster. You have CPUs now, you have disks, you can parallelize reads, you have memory that is distributed, so you have, like, if in an ideal case, a lot of distributed memory that you can use, and so you have a very powerful machine to do batch processing. The problem that you had in the past with processing, the problem that I had with my server processing the log files, it was not just the storage and keeping up in time. The problem is that if you have too many log files, and you want to do a sum or an aggregate function, you have to load the entire data set somehow. So you have to read the data, and eventually you run out of main memory. And what you typically do, and I've seen this at customers as well, and friends of mine that do the same thing, you beef up this one machine. You give it like as much RAM as you can, you give it as fast disks as you can, but eventually you hit the roof. That's it, right? So if you have 72 gigs of RAM, then you can't go much further. You can, like, have machines with hundreds of gigabytes of RAM, but where do you draw the line? Eventually this gets really expensive, and you still somewhere top out that processing. Now, the batch processing has the advantage, it can just keep a little bit in memory, because it can use a disk to do the computing. You don't want to have this happen, because using disk, as you know, is much slower than memory. But if you optimize the MapReduce job that you run, you can ideally keep as much in memory as possible. This is like a black art. That's something that you can spend months and months on optimizing your MapReduce jobs to get them right. There's a couple of screws you can turn, and then ideally it goes as fast as it can, but it's batch-oriented. So you trade the size limitations with time. You gain time, but you gain size, but you're losing time. You just have to wait for it, right? So they run for a few minutes, hours, days even. So this is not a real-time query. So this doesn't really help that much. So the next step that we see. So this was all the rage a few years ago. So when I started 2007, I joined Cloudera in 2010, end of 2010, and they make their money by helping people running these clusters. They basically just consult. We have a distribution that we give out for free, and we go to customers and say, okay, well, what do you need to do? And they say, well, we need to crunch these numbers, we need to run this data. We have we collect like a terabyte a day or whatever it is, it's more than terabytes at times per day, and we need to somehow crunch these numbers. And you have to come to terms with how many machines you need, and eventually, though, everything is taking time, and you can optimize it, and then still, you reach sort of the point where you say, time is money. Now, I've done this the last few years. This was done at many large companies. Yahoo started it, and they talked about it quite publicly. So you all know the story if you followed that. So what they have done is, when you go to the Yahoo front page, and you serve a few pages through, like you go to cars, or you go to some arts pages, if you come back 5 minutes later, the homepage already adopts to your likings. So you already shows you recommendations that follow what you have done 5 minutes earlier. And that's not real time. That's like 5 minutes. That's getting there, but they're actually using really, really small MapReduce jobs to do this over and over again. And Ted mentioned this as well yesterday in his talk. This is like you're getting to this point where you actually bastardize Hadoop, because it's not really built for anything less than, say, a minute or two. And what can you do in a minute or two, right? So it's somewhere in batch processing, there's an end to it. You can only go as fast as you can, and then you're basically done. You can't do much more. So you have to bridge somehow the gap between a batch and now. But what does it really mean? Right? So the idea with real-time, often when people say we real-time things, is often faster than batch. 5 minutes to now. So that's basically what we try to achieve. Could be more, could be less, but somewhere it's a range there. So the 80-20 rule applies. Hadoop solves a lot of things easily, 80% fairly easy, but then the last 20% gets really complicated. And don't overdo it there, because this can be really difficult. So looking at the stopgap solutions here, what you can do is you can do something in memory. Memcache, Membase, Gigaspaces or so, or you can do relational databases, MySQL, Postgres. So anything that you need to cache in between what batch does, what Hadoop does, You can put a database in between, but then you base back to the LAMP stack, the same sort of problem set where eventually this database gets under heavy pressure because the site generates so much data. So who knows? If you do it in memory, if that server crashes, the data might be lost. So how do you do persistency? Finally, you do this whole, with buzzwords, of course, NoSQL, right? This whole NoSQL thing, Cassandra and HBase. So Mongo, any of those go, or even BerkeleyDB, which is a NoSQL database. So you somehow construct this sort of combination as a complemental design. And again, this is from practice. I've done this with customers. So everything I'm telling you now is I've done this, and it works good or bad, basically. So they have their pros and cons. So you keep the backup in Hadoop. It goes into Hadoop, and then basically you stream it also over to HBase. And if you get under pressure, you optimize how you put data into HBase, which is the bulk import and batch puts. So there's a couple of APIs in HBase that help you to do this in larger styles. And as Alex has given a talk as well earlier, there's lots of work being done to somehow make this faster and faster. So because you have to keep up with what's going on the front end. So that's an idea. The other one is this. So hang on. Yeah, the problem is this. You have to do some mitigation planning. HBase is, and I have written the book, so I'm not an authority really, I'm just another user, but I can tell you that my past years, 2007 to 2009, I don't even want to talk about it, because it was like awful back then. It was like really unstable, the thing crashed, data loss and whatever. It's much, much better today. But I'm still I have been burned more than once, so I'm twice or 10 times shy. So I'm just saying, I cannot tell a customer in their face that HBase is going to be rock solid. That's it. So if they say, well, we needed something rock solid, then I say, then it's not HBase, right? I can't. In the future, I will, and I'm sure we get there. We all work towards this goal, and it's gotten much, much better. But as I said, I can't guarantee it. So the idea is that instead of somehow, what can you do? Like you can do some disaster recovery. You can basically say we use the export function, we export stuff. But what happens if HBase completely crashes? Then you can't really get to it. Copy table, there's a functionality in HBase called copy table, so you can copy between clusters. That's not consistent because there's no snapshotting yet. That's sort of a hot topic as well, snapshotting. But we talk about what is current, right? So we don't have this functionality. So the idea that you typically come up with is this sort of combination. You say, okay, take out HBase from that real-time layer, put it just next to it. So do it this way, basically. So we put it that way and have HBase here in the back. And then you have log processing in between, where you just say, well, whatever comes in here, I can process and put into HBase and feed back to the website. I'm missing an error here. There was an arrow that showed basically the connection there. So you can feed it back into the front-end system. So here the idea is that we always store in Hadoop first. We put it into Hadoop. And on the other side, we put it into HBase, aggregated or processed. And that we make available to the front end, to our website. So if something happens, we can cache it, we can react to it. We can have multiple clusters here. We have more delay that we can take into account. This is not real time. So we're buying now, again, stability for latency. So if we can't rely on this one, we have to put it a layer back. And one of the tools, and there's a talk after this one in, I think, the main room from Nicholas Spiegelberg. He's one of the Facebook developers who worked on Facebook messaging and insights and a couple of others. They use HBase in a large-scale deployment. And this is just an overview of what this does. So I'm not going into detail, really. If you want to know more about the projects they do, I recommend his talk. They're doing like 20 billion events. This is an old data. This is like from a public slide from like a year ago. So this is more now. But just gives you an idea. They do like a lot of events. They have counter updates, updating something, and they use a pipeline. What is this really used for? What they thought is, okay, if we cannot have HBase directly in the path, let's save everything to HDFS, process and aggregate the data, so that we get like numbers and counts, and update that as counters directly, as total counters in HBase, so that we get something that which I call a live OLAP cube. It's like it's not totally like an OLAP conformant thing, but it's like instead of doing anything where you have to aggregate sums and any of these sort of dimensions as you have to do with like a ROLAP or MOLAP, one of those cubes where you have to do the computation. Here they said, you know what? As things come in, let's go through like this pipeline, aggregate somehow, and write this into HBase so that when at read time, when we need to know how many users did we have out of Germany, say out of Berlin, mail, and so on and so forth, they have a counter for that. So there's all pre-materialized OLAP cube so they can get to these counters. And that pipeline now is what has to be real time. They have to bring this down to as low as possible a number, so that when the event arrives, by the time this goes through here and HBase is updated, which then feeds the front end, this has to be as fast as possible. And they have two layers there. They have a collection layer. You have a like button. You can put this on your website. If someone loads your website and the like button is displayed, that's an impression. So they know, okay, someone looked at this site. That's the first one. It's like an ad, really. And then if someone clicks on it, that's like a click-through. You can log that event. So you're saying you just basically okay, view or click, 2 events. But since typically you don't log out of Facebook, it means that this like button knows very well who you are. It has all the details. And that goes back into the system. So this is not just 1 event or 2 events. This actually fans out in hundreds and hundreds of events, like counter updates that have to be done in parallel. So this has to be as fast as possible. So they're using Scribe to do this. They have their own tool that was out before anything else. They created this. It uses the aggregation, does the file rolling, and stores it in HDFS. So that's the intake layer, the collection layer. You can do this with Scribe because it's open source, or use Flume that I had in my charts earlier in the diagram. So Flume is part of the ecosystem. So already we have something, just because it's like done within Facebook, there's a replacement or the same thing you can use open source. So that's not hindering you doing the same thing. Then you have a filter layer. That's where they use, it's called PTAL, Puma tailing, or whatever. I don't know exactly what it means, which tails the logs in HDFS. So as things happen, someone looks at the other side, the impression is being logged, so a line is being logged in the log file in HDFS, which says impression of someone looked at the site, here's the IP, here's basically all the typical web server log details. It's like one line that's been written. This thing listens to the file and says, oh, something happened. Take this out and wait for a few more to aggregate and somehow filter this out by a few rules. So that's basically done here. So it uses some filters to filter this out into events, different types, and goes through basically and is written out. So Flume covers parts of that as well. PTAL is not open source yet. So there was talk about open sourcing this, but I don't know if it's actually going to happen. But Flume has filtering capabilities already built in, so you can use the same tool as well. Then you have the batching layer, right? This is where you then say, okay, they use their tool again called Puma, which then gathers a few of these events, aggregates them on the fly, and then once it has aggregated, here's about a second, which is a couple of tens of thousands of updates, because this goes really fast, it then writes it out into HBase. So there's like a sort of like an aggregation and sort of like a batching layer on top. It's only a second, so it adds some latency here, but overall, it's not that much, and it helps a lot to take the pressure out of HBase. But then basically, that's how they do this. And you can, in 092 of HBase, we have a new tool called, or new framework called coprocessors. Think of like triggers or stored procedures in databases that you can actually move this sort of aggregation into the server side if you are willing to do so. So that's back then they didn't have this, so they wrote this as a layer on top of that. They use counters, the HBase counters in this case, where they just aggregate per domain and URL. So if you have that like button on your homepage is basically part of your domain name, and it has a URL. So based on the URL and based on the domain name, they have counters. Domain name for the entire set of counters, for the entire domain. And per URL, they have a counter so they can say on the homepage how often things have been. And this is basically how they aggregate. They use some predicate deletes in HBase. Predicate deletes are the ones where you can have a time to live. So they basically they update these counters and have these counters expire automatically so that the system takes care of removing them during background cleanups. So they use this built-in feature that HBase has, and that's all, really. It's all built in HBase. Again, you can have that. It's for free. Then the key design. We don't go into redesign, but just giving you a clue here for those who have looked into like HBase and key design. They basically have these domains. That's the reverse domain, which is just so for sorting and ordering. It's a bit more convenient. And create the MD5, attach the original, and that's the domain key. That's done specifically for HBase to have a nice distribution over the entire key space. HBase is only good if you can distribute the rights across all servers, because otherwise you're hotspotting on a single machine. That's bad. We heard Otis earlier already had this as a lesson learned in his talk as well, if you have been there. Hotspotting is not a good idea. You basically go down to the performance of a single server, and they can kill the entire cluster, because this one fails, this fails over to the next one, which fails, and then fails over again. There's no degradation. HBase, I like HBase a lot, but it doesn't have any built-in functionality to stop you from killing the entire cluster that way. So that's so it's per domain and per URL. They have these keys, and that's the schema. So they have a row, and in the row they have in HBase you have these column families where you can group columns together for better analytical queries at the end. So they have one here for hourlies, dailies, and lifetime counters. Here in this case, it's not so much it is also for the analytical queries that they group them by column family, but the time to live in HBase is per column family. So they set the time to live on this column family to a few hours and then a few days here, and for this one they keep it open to keep the data around and delete them manually, for example. So, but otherwise, these are all pre-materialized dimensions of an OLAP cube. And that hammers it in. They had to stagger this with the Puma layer and the aggregation layer, but they're keeping up 10,000 inserts per second on a single server constantly during peak time. So that's quite impressive, and it works. Right. Now, the next step. We have seen all of the combinations. HBase is great, and I grade this out here a little bit. That's not the end of the story. So that's what I've done so far at customers. What we talk about now, and as Ted did this already, picked this up yesterday, and it's great to have have HBase or some other store behind Hadoop to somehow do the live aggregation of data. But HBase and the counters requires a lot of knowledge, a lot of fine-tuning. It might not be the best way to start out, and it still has some sort of slight lag because you're going through this pipeline and it eventually ends up in HBase and it can be served to the front end. It was about 15 minutes in the past for insights, and they brought it down to like 10 to 30 seconds today. So it's pretty good, but still not real time. I would say nearly immediate for what we understand as immediate. So the other idea here is, and we talk about customers with that, is to sort of latch on as a final component something like Storm, which is a stream processing system, which is in memory, is fault tolerant, has these built-in aggregations. It bridges this minutes and hours that you typically have from batch-oriented, or minutes when you flunge on like the HBase component. It can bring it down to even less. Right? It's still a question. You still have to aggregate somehow. You might still have a slight delay, but it's pretty good. So that's the idea. And so with that in place, you can sort of gap the last bit that you can't cover with all the other solutions. You might gray out, as I have done, HBase here. You don't have to use it. You can basically just use this sort of component, the Storm directly for the live aggregation, or use HBase in combination. And what that does basically is it moves the complexity into the application layer. Even with all the other solutions, There is nothing out of the box. There is no layer currently, no system, no framework that you can use that would give you that out of the box. Currently, all of this means engineering time. So keep in mind that if you go for anything, you want to go and close this gap, you have to put these systems together. You have to stitch them together. You have to learn it the hard way. What are metrics? How do I understand why the system's crashing? All of these sort of steps you have to go through. You do it again. So I'm waiting for this next crop of tools around Hadoop ecosystem to sort of cover that gap. But I haven't heard of it yet, like anything realistically. And the stream results can be dropped, which is great. So that means that once you have persisted the data that you have aggregated in memory, in Storm or the likes, you can write it out to Hadoop if you need it. Otherwise, you can just drop it as well or keep it there. But you have the option of keeping that to a lower contention there, to have less issues with memory. And you also, because you're only seeing data on a single machine, so if you have a cluster of these machines, it's harder to solve certain mathematical problems. Certain aggregation functions are not either you can't make them fully correct because you're only seeing a subset. So you might have some error rate, but it's much better to have the slight error rate and show a value to a customer saying you have like 1,350,255 users, although it's 57 or something like this at the end. So you could also communicate this. I have discussed this with customers. Some say we can't do that. It has to be correct. And I have customers who say, that's fine, we just put a note next to it which says, that's the estimate, and if you check 2 hours later or something, that's basically then the final number, if you write reports, for example. So that's, I have to see what happens there. So this, Nathan Martz, he termed this as eventual accuracy. So it's an interesting one. It means that you have to deal with that, again, on the application layer side. And so you're basically trading then latency, we have to trade latency versus throughput. With this one, you can get best of both worlds. So this is what we have, what I and we as Cloudera have seen at customers when we go there and talk with them. A lot of our customers are just plain in Hadoop land yet, so they haven't done any of these advanced stuff, but this is sort of the direction this entire thing is going. Questions? Ted? Okay.
There's two philosophies. One is the counter-based approach that you talked about with HBase, and it's also used in the Storm examples. They have a windowed counter. And then there's also the semi-aggregated cube approach with the combiner, which is what Otis and Semitext used and what I used in my example. And it sounds like maybe what you used in there. How would you compare those two approaches?
Well, as I said, our customers are very early on. If you talk about these topics, I can tell you that none of our customers is at this point. So for me personally, this is just my personal opinion on those. I choose whatever is what is pragmatic for the use case. So some use cases we can if you only use we have customers who only use Hadoop and HBase. So I have to use the counter approach if I have the choice. I have not done any of these Storm implementations, so any of these combination where you do that, I have to pass. I haven't seen any pros and cons yet, because I haven't seen this in real life.
Well, Semitext uses semi-aggregates into HBase and avoids the counters, they say, for performance. What do you think? I mean, you've been using HBase a long time.
Yeah, no, sure. The semi-aggregates, or in general aggregates, HBase has the problem that the write performance is bound by a couple of physical limitations, be the write-ahead log being written out to HDFS, which has to be replicated across three machines. That costs you. So HBase is not the system to do high-performance writes. It is good at writes, but it's not great. And anything you want to do, which then hammers this thing with updates, you overdo it, and the machines can't keep up. You're filling up the queues, RPC queues, and that's it. So you have to pre-aggregate. That's exactly what Puma does and P-tail, where they aggregate and keep 1 second in memory and then push it through. This has to be done that way, I think, under load. But then again, we have customers who they have a very low volume, and you can go straight HBase, and then you just avoid all of that. There's no, besides the handcrafted version like Alex did or so, and Otis, I haven't seen any library for that yet. Facebook hasn't open sourced this yet. I would love to see this coming out somewhere as a layer. But it's all hand-coded currently.
Okay, anyone else? Yeah.
Alex?
Yeah, I was just going to add that we also use this like 1 second pre-aggregation. So yeah, we have this client-side buffer, small, which reduces the amount of updates as well.
Yeah, because you can't do straight inserts, and you can't batch them really that way. It's just, you have to cache it a little bit.
Yeah, we have another question over here.
I was just wondering, because of all the systems working together, why not switch out the HBase in this scenario with a high-write solution like Cassandra?
Well, the point is, from my point of view, so again, it's just personally, is that you can use any of these components, can be Cassandra or anything else. I'm completely pragmatic. I'm not for HBase, as you might have heard. I'm actually trying to discourage you using HBase if you don't have to, because it still has its edges. If Cassandra tells you they have no edges, I don't trust this either. But I'm basically saying you can go with that and try. Why not? If you have a Cassandra shop, go with Cassandra. If you start out fresh and you use like a distribution in the Hadoop ecosystem, only HBase is part of that one. So for me, it typically goes towards HBase, but I'm not. This whole architecture can be done with a lot of different systems, but I have no numbers on that one. Neither, basically. We don't even know how well this works because Facebook is not allowed to publish that as well.
Okay, one last then. Okay, thank you very much.
Yeah, no, thank you.